The speed of light is currently the ultimate speed limit in the universe, a boundary no object with rest mass can ever cross. It travels roughly 300,000 kilometers every second, enough to circle the Earth 7.5 times in the blink of an eye, and, while this may seem unimaginably fast to us as human beings, it becomes almost insignificant when measured against the sheer scale and immensity of the cosmos, which is so vast that even light itself can seem like a tiny, wandering traveler. The observable universe alone stretches across an astonishing 93 billion light-years. And even if we were able to travel at the speed of light, we still wouldn't be able to cross it with any ease, which begs an intriguing question. If we could somehow break that barrier and move at the rate of 1 light-year every second, would that finally be enough to reach the edge of the universe? To put this into perspective, 1 light-year is roughly 9.46 trillion kilometers. And now, as we imagine ourselves aboard a spacecraft capable of covering that enormous distance in just 1 second, we can begin to wonder what it would be like to race across the stars and witness the true boundaries of space itself. We now embark on an interstellar journey, and after just 1 second of flight, we instantly arrive at the outermost edge of our solar system, a vast sphere of ice and rock, called the Oort cloud, which stretches roughly 2 light-years across and marks the very boundaries of the Sun's dominion. After 4.22 seconds, we reach the closest star beyond our own, Proxima Centauri, part of a 3-star system that serves as the fictional home of the Trisolarans from the famous sci-fi saga. After 8.6 seconds, we arrive at Sirius, the brightest star in the night sky, a blazing blue beacon with a faint white dwarf companion, both stars locked in a cosmic dance as they orbit each other. At 6.9 minutes, we arrive at the Pleiades, a beautiful open star cluster containing roughly 3,000 stars and spanning about 13 light-years, a jewel of the night that has inspired countless myths and stories. Across human history, after 10.8 minutes, we reach the Helix Nebula, a luminous shell of gas that marks the final chapter in a star's life, with an incredibly dense white dwarf resting at its center like a cosmic relic. After 25 minutes, we arrive at the Orion Nebula, one of the most beautiful sights in the night sky, a sprawling, diffuse cloud of gas and dust, where countless new stars are being born, earning it the nickname the Nursery of Stars. After 1.9 hours, we arrive deep within the Eagle Nebula at a spot called the Pillars of Creation, a scene so breathtaking that it became one of the Hubble Space Telescope's top 10 images, capturing towering columns of gas and dust that glow with the promise of new star formation. After 5.5 hours, we arrive at the largest known star in the universe, Stephenson 18, a colossal giant with a radius 2,158 times that of the Sun, a volume that could contain 10 billion suns, or roughly 1.3 trillion Earths. After 1 full day of traveling at this unimaginable speed, we finally reach the edge of the Milky Way, and from this vantage point, the entirety of our galaxy unfolds before us, a sprawling disk containing at least 200 billion stars, every point of light representing a sun of its own, a reminder of just how unfathomably vast the universe truly is. After 29 days of travel, after 115 days of traveling at this unimaginable speed, we arrive at the outer edges of the local group, a small collection of roughly 50 galaxies, including the Milky Way and the Andromeda Galaxy, bound together by gravity. After 3 years of travel, we finally realize that this local group itself is only part of a much larger structure, the Virgo supercluster, which contains roughly 100 galaxy groups and smaller clusters. After 16 years of traveling, we break free from the boundaries of the Virgo supercluster and find ourselves within the massive Laniakea supercluster, a cosmic structure spanning 520 million light-years and containing roughly 100,000 galaxies. After 31 years, we understand that even Laniakea is just a tiny piece of an even larger complex, the Pisces Cetus supercluster complex, within which the Milky Way, the Virgo supercluster, and countless others reside. After 430 years of this journey, we witness the universe on its largest scales, its filamentary structure stretching across space, comprised of countless superclusters and galaxy groups, a cosmic web that contains at least 1 trillion galaxies. And after 1,458 years of traveling at this incredible speed, we finally arrive at the edge of the observable universe, roughly 46.5 billion light-years from Earth. Yet even this is not the true end of the universe, it's merely the limit of what we can currently measure. Some scientists speculate that beyond this horizon, space stretches on infinitely, making it almost unimaginable that even traveling at this blistering pace, we would ever reach the actual edge. It reminds us just how tiny and fragile humankind truly is within the vast expanse of the cosmos. When it comes to the question of extraterrestrial life, it's only natural for us to be filled with curiosity. And it's not just ordinary people. Even scientists have been searching for signs of alien civilizations for more than half a century. Since the middle of the 20th century, researchers have been scanning the skies for any hint of their presence. Although we haven't found definitive proof, that hasn't stopped the search. Scientists understand that in a universe containing countless stars and planets, it's highly unlikely that life is limited to tiny planet Earth. In 1964, Soviet astronomer Nikolai Kardashev proposed a scale for classifying alien civilizations based on their ability to harness energy. This became known as the Kardashev scale, and it defined 3 levels of advancement. A Type 1 civilization can utilize and control all the energy available on its home planet, including its moons. A Type 2 civilization can harness the total energy output of its star, and a Type 3 civilization can tap into the energy of an entire galaxy by this measure. Humanity has not even achieved Type 1 status. We can only utilize a tiny fraction of Earth's resources, and we have yet to master controlled nuclear fusion. At best, we hover around a 0.7 rating, nowhere near true mastery of planetary energy. The universe itself is unimaginably vast, with distances measured in light-years. For example, Proxima Centauri, the closest star beyond our Sun, is still 4.22 light-years away, a journey that would take light itself over 4 years to complete. So, if an alien civilization were ever to reach us, it would have to be far more advanced, possessing interstellar travel capabilities and technology that almost certainly dwarfs our own. To put this in perspective, the furthest human-made spacecraft, Voyager 1, has traveled for 44 years and has only managed to cover roughly 22.6 billion kilometers, a tiny fraction of the cosmic ocean that separates the stars. It would take tens of thousands of years just to travel beyond the boundaries of our solar system. And this is why, if an alien civilization ever came to Earth, humanity would stand virtually no chance of defending itself, even if we unleashed every nuclear weapon we have. To such a race, nuclear bombs would be nothing more than primitive relics, a technology so basic it wouldn't even penetrate their spacecraft's defenses. Those who have watched the movie Independence Day might remember the scene where humanity fires a nuclear warhead at an alien ship, only to see its protective shield remain completely intact. It's not hard to imagine just how advanced a civilization with interstellar travel must be. But then again, an invasion of Earth is largely a hypothetical question. After all, our planet is an insignificant speck in a universe teeming with countless others. An advanced alien species would have little reason to waste energy and resources, crossing light years of space just to attack us for them. Humankind would be akin to ants. The Sun, a massive, blazing sphere of plasma, is the undisputed ruler of our solar system, containing an astonishing 99.86% of its total mass. To the naked eye, it appears serene and gentle from Earth, but as we draw closer, we realize how extraordinarily turbulent it truly is. Recently, the European Space Agency, ESA, and NASA released the closest images ever taken of the Sun, captured by the Solar Orbiter spacecraft from a distance of roughly 77 million kilometers. These images mark the first time humanity has observed the Sun in such intricate detail, revealing a surface teeming with activity. Around 4.2 million tons of matter are converted into energy every second, and within its corona, the Sun's outer atmosphere, temperatures reach a staggering 1 million degrees Celsius, hundreds of times hotter than its surface. For a long time, this paradox puzzled astronomers. Why is the Sun's corona so much hotter than its surface? Thanks to these new observations, astronomers have discovered countless tiny, rapid-fire flares on the Sun's surface, called campfires. Microflares roughly 1/millionth or 100,000th the size of ordinary sunspots. These tiny explosions may be responsible for heating the corona to such extreme temperatures. Yet the precise mechanism by which these microflares form is still unknown and will require further investigation. Around 250 million years ago, at the end of the Permian period, the Earth suffered the greatest biological extinction in its history. Nearly 70% of terrestrial vertebrates and 96% of marine species disappeared from the planet. The sheer scale of this event brought life on Earth to the brink of collapse, with only a handful of reptile species and early mammals managing to survive. This catastrophic extinction also marked the transition from the Paleozoic to the Mesozoic era. So, what caused such an immense die-off? According to paleontologists and geologists who have studied ancient rock layers in Siberia, this extinction was most likely triggered by a massive, unprecedented volcanic eruption. At the end of the Permian period, Siberia was engulfed by continuous volcanic activity that lasted for hundreds of thousands of years. The lava flows blanketed an area of roughly 1.6 million square kilometers, releasing massive amounts of toxic gases, volcanic dust, and acidic particles into the atmosphere. The resulting darkness and plummeting temperatures disrupted photosynthesis both on land and in the oceans, causing food chains to collapse. Even when the volcanic activity subsided, the dust and debris settled, releasing stored carbon dioxide. That triggered global climate changes and further reshaped life on Earth. As terrestrial species were unable to adapt to these drastic climate changes, countless creatures perished, and a cascade of events unfolded in the oceans, triggering widespread anoxia, acidification, and ultimately the collapse of marine ecosystems. The result was an extinction of unimaginable proportions, with roughly 90% of all species on the planet disappearing from existence, marking the end of the Permian period. Mars, the red planet, is a desert world, and yet it's one of the planets most reminiscent of Earth, with its towering mountains, deep canyons, and a thin, frigid atmosphere. It has long been a focal point of human exploration. Since the 1960s, nations have launched countless missions to unlock its secrets. In China's case, after the failure of the Yinghua 1 probe, a new chapter in its journey to Mars began. On July 23, 2020, a Long March 5 rocket lifted off from the Wenchang Space Launch Center in Hainan, carrying the Tianwen-1 spacecraft. After more than 2,000 seconds of powered flight, it successfully entered its intended orbit, gaining enough velocity to break free from Earth's gravity. The spacecraft would spend over 7 months traveling through deep space, and between February 11th and February 24th, 2021, it would arrive at Mars, entering its orbit and preparing for 3 critical objectives: orbiting, landing, and exploring. The landing itself was the most challenging endeavor of all, due to the immense distance between Mars and Earth. Long communication delays meant the probe had to operate fully autonomously during its descent, a tense and critical moment that became known in aerospace history as the 7 minutes of terror. After a successful landing, Tianwen-1, as China's first fully domestically developed Mars probe, began its mission to study the red planet. It would analyze the soil composition, surface morphology, and subsurface structure, investigate the ionosphere and climate, and map the distribution of water and ice. The data collected will help lay the foundation for future human missions and potential colonization of Mars. Although China is still in the early stages of its journey compared to other nations, its ambitions are clear, and in the years to come, it may well stand at the very forefront of interplanetary exploration.